Right, well, let's go ahead and get started. Hi, everybody, and welcome. Thank you for joining our Young Wave Makers webinar tonight. My name is Katie Bairnalvin, and I'm the program manager for the Cape Perpetua Collaborative, and we are just so thrilled to have you all here. This is one of our mini programs, but by far our most popular speaker program. So this is very exciting that we're joined by young and emerging professionals such as Sof here. So tonight we're going to be hearing about Sof Fox about some science communication and celebrating the amazing area of the Cape Perpetua area and tell you a little bit more about marine reserves and our collaborative in general. So let's just jump right into it. So our organization, the Cape Perpetua Collaborative, it works primarily in the Cape Perpetua area. So generally speaking, that's from Yachats down to Florence. And this area encompasses Oregon's largest marine reserve. So what that means is we have the largest area designated in Oregon state waters that is specifically set aside as a living laboratory for science and conservation, which is something that is very interesting, and it's very interesting to study. Oregon actually has 5 of these areas, and like I said, this is the largest. And then we're also next to the Marine Reserve, we have the Northern Marine Protected Area, and then the Southeast Marine Protected Area, and then the Seabird Protection Area. So similar to that Marine Reserve, they restrict a lot of the human activities, but they do have varying different authorizations of activities that can occur in those areas, but they still are providing conservation values. But unlike the Marine Reserve, the true Marine Reserve, the red box, that's no take of any kind, no industry of any kind, just science, just conservation in that area. We also have several programs on land that I'll talk about in a little bit, and that's in the Cape Perpetua Scenic Area and in the National Forest adjacent to this marine reserve. So this is just a really incredible area that unites the land and the sea. So that's what our programming tries to focus on. So who we are? Well, in 2017, a bunch of partners came together. So partners from local NGOs, from state and federal agencies, also the Confederate tribes of the Coos, Lower Umpqua, and Siuslaw Indians came together and were like, hey, we're all doing all this work in this area. We should form a collaborative. And so the whole mission is to foster conservation and collaboration within local communities for scientific exchange, management, awareness, and stewardship from the land to the sea in and around the Cape Perpetua Marine Reserve. Today, our founding partners are listed here on the slide, but today we have many other partners that are not listed here. So we have additional NGOs, additional agencies. We're always expanding our collaborations with the tribal entities. So we got a lot going on and a lot of good organizations involved. We offer some really amazing programming, and we encourage people like you to always come out and participate. We have several opportunities to engage in citizen and community science, such as sea star monitoring, marine debris surveys, bioblitzes. We just wrapped up some fungi bioblitzes, which were incredibly fun. And we also partner with Audubon for some seabird monitoring. So those are all opportunities that interested people can come out and participate in. We also, in the summer, offer some field learning opportunities, such as our tide pool tours, and that is one of our most popular programs. So stay tuned for when we release those dates. They're free tide pool tours. They're amazing, super fun. And also in the summer, you can find our Marine Reserve ambassadors out along the 804 trail, and they're out there providing just answering your questions, whether that be about seabirds or the best place to get coffee in town. They're there for you. And we also host community events in the winter time too. So those tend to be more indoors or online, like this one. But we just wrapped up our biggest event of the year, the annual Land Sea Symposium. You can find that on our YouTube channel and on our website. And soon, we'll be talking about it in a little bit, but soon we're also going to have some more community nights that we call that unite art and science together. So please reach out to us if you ever want to be involved in any of that. And then, of course, it's the holiday season, so we have to pump out our merchandise. If you are interested, the profits go directly to us and support our programming. So if you are interested, you can visit our bonfire store. You can pick your size and your color, and they get shipped directly to you. And it's an excellent way to support our organization. They're very soft and cozy shirts too, I might say. All right, and just to wrap it all up here, feel free to connect with us. So we have our website, we are on Facebook, we're also on Instagram. So please follow our social. We are always posting pictures and fun facts and events going on in the area. And lastly, coming up, we have some more events. So on the 9th, this Saturday, we actually have an in-person event. So that's with Dave Colin of the Xerxes Society, and he's going to be talking about pollinators and what pollinators mean, not only to our area, but the world. It's absolutely fascinating talk. So that is in person at the Cape Perpetua Visitors Center. Definitely encourage you all to come on out to that. And then we have another in-person talk coming at the Cape Perpetua Visitor Center with Margaret Treadwell about conserving the Cape Foul Weather area, which was recently designated. Like I said, we have community nights coming up, so we're still working on finalizing those dates and activities, but there are things like building a community mosaic, watercolors, painting, beading, all things like that. So we just encourage you to stay tuned to our website and our social to stay involved with our events and know what's coming up next. All right, so with all of that, it is now my pleasure to introduce Sof Fox. I met Sof actually when she was interning down at the Port Orford. Well, I'll read from the description here in a minute, but down in Port Orford, we met at the Redfish Rocks on the Dock event. It was actually my first time at that event, and I really enjoyed the area and started talking to Sof, learning what they were doing over the summer and through their internship and all the work that they are doing, and was really impressed. So invited Sof to come and be a young wave maker with us, and here we are. So Sof is an undergraduate and marine biology student at the University of Oregon with minors in science, communication, environmental studies, and dance. They are interested in the connections and overlap between disciplines. They recently served as an Oregon Sea Grant Summer Scholar, working on marine reserve interpretation and science communication at the Redfish Rocks Marine Reserve in Port Orford. Enthusiastic about ecology and human connections to the environment, Sof hopes to work with coastal communities on solutions to increase resiliency against the climate crisis. So like I said, very excited to have Sof here. And Sof, I will hand you over the screen share and you can take it away.
So today I am so excited to be here. Thank you to the Cape Perpetua Collaborative for inviting me. I will be talking about science communication. Just move this out of the way. Perfect. All right, so just to give a little bit of an overview of what I will be talking about today, I'm going to start with a little bit of an introduction on who I am. We'll get into what science communication really means, and then why we need science communication and how we can make it effective. Then to wrap things up, I'll talk a little bit about how I personally have applied science communication in my undergraduate career and other ways for undergraduates to get involved in research and science communication and things like that. So just a little bit about me. I am originally from Seattle, Washington. You can see a picture here. I've always loved the ocean and everything that lives around it. So pursuing marine biology kind of felt like a bit of a natural path. I am currently pursuing my Bachelor of Science in Marine Biology at the University of Oregon, where I have also spent time at our marine lab in Coos Bay called the Oregon Institute of Marine Biology. In addition to my marine biology major, I am also pursuing minors in dance, environmental studies, and science communication. We'll especially get into that science communication minor a little bit later on. And I am also working on an honors thesis on a specific species of nudibranch that has a cryptic species complex, which if you aren't familiar with what a nudibranch is, it is a type of sea slug. So like Katie mentioned, I spent the summer working as an Oregon Sea Grant summer scholar down in Port Orford. And I was specifically one of the science communication and marine reserve interpretation interns with the Redfish Rocks community team. So this really set up a lot of my work with science communication, and I'll be mentioning that a little bit later today. So to get into what science communication is more broadly, it's still very much a developing field, and so it can kind of be hard to give it a specific definition. So I thought I would provide a couple different ways. From So What's Science Communication Then, which is a blog post written by Joe Bailey, they write that science communication could be categorized as a discipline, a practice, a professional activity, or all of the above. So this really gets into the idea that science communication can take a lot of different forms. For some people, it can be their entire life's work, but in some cases, it can also just be one moment of practice. The National Academies of Sciences, Engineering, and Medicine report calls science communication the exchange of information and viewpoints about science to achieve a goal or objective. We'll talk about goals and objectives a little more later on, but this kind of gets at that idea that there's this exchange of information, but also perspectives, because this information doesn't really exist in a vacuum. People have relations to it, and how we relate to that can help us achieve specific goals. And then something that I just threw in there is I like to think about science communication as any way of conveying information about science between multiple groups. This can be just between two people, a bit of a conversation, but it can also be larger. So it doesn't have to be just two people. It can be 10 different groups all coming together, as long as science is being discussed in some way, shape, or form. All right, I'm going to start talking about a couple different models of science communication. So models are very important in communication more broadly, as they can provide us with a framework for how we go about things. So they can give us some steps, some ideas, and ways to think about how we are communicating. One of the models that I'm quite familiar with, and that many of you have probably experienced as well, is called the deficit model. So a little bit of a diagram on the left, but it's very much this kind of top-down way of disseminating information. Usually the scientists or the experts are giving this information to the public. They're presenting science as facts, but not necessarily telling the public how to apply that information or what they can do with it. One thing about the deficit model that can be really, really useful is the way that it can help provide this sort of baseline knowledge and mass communication. We have a lot of systems already in place for deficit models. You might think of newspapers or even alerts from your phone or something like that. It can be a good way to get information out really quickly. One of the problems with this model is that it sort of allows the public to kind of be seen as this ignorant group that needs this education and needs to be given this information because they don't already have it. And that idea was kind of brought about by something called the Bodmer Report, made by the UK Royal Society's Public Understanding of Science report in 1985, that kind of looked at a lack of public knowledge on what they considered to be basic scientific facts in the early 1980s. So they decided to start kind of incorporating this deficit model as a way to create that baseline and make sure that their public was educated on what they considered to be important scientific knowledge. One of the problems with this, though, like I was mentioning, is that knowing these facts doesn't necessarily translate to being able to usefully apply them. So even if you can do really high levels of math, or you can talk about photosynthesis, that doesn't mean that you truly know how to use that information. So some examples of what the deficit model can look like might be podcasts, social media posts, videos, presentations. But one key thing about this is that it's usually only in one direction. So there's no feedback being received about this. And that kind of leads us into this dialogue model. So in the dialogue model, the public is kind of conversing and giving feedback on this communication, giving us more of a two-way engagement as opposed to that more one-way engagement that we saw in the deficit model. This could look like something like an interactive presentation or a discussion where you're in conversation, giving feedback. And in that, programs might specifically be asking for feedback. So one example that came to mind for me that was recently relevant on the Oregon coast were sea otter reintroduction open houses that were hosted by the U.S. Fish and Wildlife Service. So at these events, U.S. Fish and Wildlife was coming, presenting information to the public at these open houses that they were invited to, but they were also asking for feedback from those community members that came. So that way they're having that back and forth, giving the information, but also asking for input and seeing what is important. These can also look like roundtable discussions like what we have in that picture, or sometimes certain classroom settings can have this as students give input, students engage with the teacher, maybe they're working in a group, that kind of idea. And then the last model we're going to talk about today is called the participation model. In the participation model, you have groups working together, kind of working on developing this communication. So the emphasis here is a little bit less on teaching and just relaying information and is more on communicating these scientific processes and establishing trust. This active engagement that you might find in a participation model type of science communication helps contribute to establishing that trust and can lead to more intersectionality within the communication. Some examples of this might be citizen science, which you heard a little bit about from Katie with the BioBlitz programs that the Cape Perpetua Collaborative does. And another way that that kind of comes up is in apps like iNaturalist, where anyone is able to go out, look for things in the tide pools, on land, anywhere really, and identify them and help contribute to science. Another example of this on the Oregon coast is Reef Check, where volunteer divers get trained and then they go out and they help conduct surveys on reefs, whether those are coral reefs or kelp forests here in Oregon, and that kind of thing. So when you're looking at programs that involve citizen science, you really have those community members coming in and doing a lot of the hands-on work. And what this can really do is it can allow for those people to become more engaged and become more interested in the research, the science that they're doing, and through that also become more informed in it. Another example of this kind of participation model is how a lot of the Marine Reserve program, and they have their community team models, how those came together with community groups proposing marine reserves, as well as working together to keep them running, as Katie kind of described with the collaborative and all of the organizations that are a part of making that work possible. All right, so that's it for our models. But now I'm going to get a little bit more into why we need science communication and why it's important. There are a lot of decisions that are made relating to science, both on the side of scientists as well as the public. So scientists have a lot of decisions to make, some of which may include even just what kind of science they're doing. A lot of times, scientists may not really consider perspectives from the public and may just go on and do whatever science that they think is valuable or useful. But when we include science communication in this process and get input from the public, we can carry out science that is really important to community needs. On the other side of this, if the public needs to make decisions, it might be important for them to understand science. And with that kind of comes this idea of needing to have an ability to understand numeric information, which is also called numeracy. It's like the idea of literacy, except you're looking at numbers. A lot of times we might be presented with statistics, numbers get thrown at us, but they might not always mean a lot to us. And so when you can have science communication, you're able to really explore what that information truly means and how you can apply it. And then through that, also drawing attention to what information is particularly important within those numbers or within that scientific information. It's also really important to get feedback, information, and involve community members. It's our science communication and just our science in general isn't as effective if we don't hear all the perspectives. We can't necessarily come up with the same solutions, and with more people and more community members involved, we can get a lot more creativity perspectives that will then allow us to come up with better solutions that we wouldn't have considered otherwise. I think that this is especially important in the context of the climate crisis. Making sure that we have as many people coming up with ideas and working to find solutions will enable us to achieve the best outcome. So now that we have a bit more of an understanding of why we need science communication, I'm going to get into what can make science communication effective and what we need to do to ensure that our science communication works. One thing here is that we want to make sure we are considering our audience. If you're going to talk to a group of kindergartners, that's a very different type of communication than if you're talking to a group of adults that is already knowledgeable and interested in the subject you're telling them about. And some examples of that are just thinking about the kind of engagement that you will need to get from the audience. Like I said, if you have this group that is already really interested in the subject, you don't need to give them much of an introduction or get them as excited about the topic. Whereas if you have these group of kindergartners that may have never heard of whatever you're going to talk about, you need to find a way to connect them to it and get them excited about what you're going to say. Using this kind of idea of considering the audience, it's also really important to establish trust and credibility. If you are an outsider coming into a community that is not familiar with you or your work, they don't have very much of a reason to trust you. So if you have the opportunity to work with that community more and build up that trust, then the science communication is more likely to be effective because they have reason to believe you and take into account what you're saying. Another thing to consider when we're doing science communication is what our goals and objectives are, or what do you want to accomplish with this? So there are a lot of different kind of frameworks for what the different goals of science communication may be. And these may range for things like sharing recent findings and excitement for science, which could be something like just having a conversation with a friend, sharing something on social media. But they could also be a lot bigger picture to ensuring that a diversity of perspectives about science held by different groups are considered when coming up with solutions. So there's quite a range in here, and I think there are about 4 more goals within this list in between that. And this is from the National Academies of Sciences, Engineering, and Medicine report that I mentioned earlier as well. But really thinking about what your overarching goal is before you jump into science communication can help frame this and allow guidance for more specific objectives throughout your communication. Something else that's really important is looking at evaluation and feedback. This can help make sure that you are improving future communication and creating a cycle of learning from your own mistakes and growing for more effective science communication. So evaluation can include things like surveys, where you check back in after doing some form of science communication and see what went well. Maybe you give some sort of quiz to see how much information people gained from your science communication event. And from that, you can get an idea of what worked and what didn't. Another idea that is a little bit newer in science communication is called inclusive science communication. And sort of what that's described as is prioritizing inclusion, equity, and intersectionality as central parts of the process and desired outcome. A lot of this comes back to considering our audience, making sure that we are including everyone and taking intersectionality into account as those different audiences will have very different perspectives on different science topics. Great. Now I'm going to go ahead and say a couple things about some of the work that I have done with science communication. So one thing I did this summer, as Katie was mentioning, is I was an intern with the Redfish Rocks community team, which is another one of the marine reserves. As part of this internship, I developed and hosted a junior ranger program. So you can see on the right, I am on this beach with a group of people. I hosted this program at the Humbug Mountain State Park, which is very close to the Redfish Rocks Marine Reserve. You can't see it in this picture because it was a very cloudy day, but out on the water, you can see the Redfish Rocks that make up the reserve. So at this campground, there are a lot of families, especially in the summer. And so I wanted to take advantage of that and be able to teach them about this reserve, because I think a lot of people, especially just traveling through, aren't necessarily aware of the Marine Reserves program that we have in Oregon and may not be aware that they're right next to one. So a couple times throughout the summer, I went out and hosted this program. I started with an introduction of marine reserves, talking about what they are with the different protections that they have in place, as well as the implementation of marine reserves specific to the program here in Oregon. From there, after creating a sort of baseline of information, I would lead the group on a walk from the campground down to the beach, where they could then see the marine reserve. As soon as it was in view, I taught them a little bit about the marine reserve itself at Redfish Rocks, the types of research being done, and the organisms living there. We continued to walk around the beach, exploring, learning about the site through what interested different participants on the beach. So it can be hard to contain a group of children on a beach, but there were so many things around that they were really interested in just picking things up and bringing them to me. And what was so great about this is that that gives me the ability to teach them about what they want to learn about, which also makes them more engaged. So one day when we were doing one of these programs, I had a kid who was really, really excited about kelp. I had picked up just a first little chunk of seaweed that had washed up on the beach, and we talked about the holdfast, the blades, different parts of the kelp. And from then on, every single type of seaweed and kelp they were finding on the beach, they would bring to me. And by the end, it was very clear that they could kind of ID these different parts of the seaweed on their own, which was really exciting. And also kind of an example of that idea of evaluation and feedback. I could see that even though they weren't very familiar with seaweed at the beginning of my presentation or program, by the end of it, after looking at a bunch of examples and talking through them, they were able to just tell me what they were looking at without any sort of prompting. Another aspect of these programs that I carried out was a more creative project of drawing in the sand. So we had already established a little bit about what marine reserves are, what they're useful for, and some of the different organisms that the Redfish Rocks Marine Reserve specifically works to protect, which would be rockfish. I then asked these campers what they imagine their own marine reserve looking like. Like, if they could create a marine reserve, what would they want to protect? What would they want to have in it? What would they hope would end up in the marine reserve? And it was really cool to see all of these kids just drawing in the sand, coming up with their ideas, and letting their own creativity shine through. Again, this comes back to that idea that the children were really guiding the experience. They were showing me what they were excited about and what they wanted to learn about. So I will not be at Redfish Rocks next summer, unfortunately, but I have set up a guide so that future interns can carry on this program and keep this work going through the campground at Humbug Mountain State Park, hopefully reaching even more kids about marine reserves. So I mentioned earlier that I am a science communication minor. I'll get a little bit more into the specifics of that later, but this term I took a class called Living in Our Valley. And a lot of what this was kind of looking at the intersection between art, communication, science, and storytelling. For this, I decided to create a dance piece to tell a story about something within the Willamette Valley, which is what the class was focusing on. I decided to look at Finrock Reach, which is a restoration site along the Mackenzie River, looking at restoring historical floodplain and doing a rebraiding of the Mackenzie River. Here in this picture on the right, you can see a group of volunteers that attend a First Fridays at Finrock Reach volunteering event, and those are put on by Mackenzie River Trust, which is the organization that has kind of been heading this restoration project. So the first Friday of every month, with the exception of winter when it's a little too cold and rainy to get volunteers out there, they host these events and have people come out and just do work with removing invasive species, planting, that kind of thing. So while I was at this event, I was able to connect with some of the volunteers who attended as well. And after the event, I followed up with them and conducted some interviews. In these interviews, I was able to talk to all of them about this restoration project. Some of them, it was their very first time at the site, and they had never been involved with Mackenzie River Trust before. But for others, they live right in the area. They could walk down to this site, been living there for decades, and this was kind of an area that was really important to them. They'd been able to see the changes as this restoration project has been taking place the last couple of years. So I gained these different perspectives, hearing their thoughts on the importance of this restoration project and restoration projects in general, what they hope it'll look like in the future. Yeah, and sort of how important restoration is. I then use these interviews as some audio for the dance piece that I created. That piece that I just showed in the video is very much part of a work in progress. I'm hoping to continue developing that and working on it, hopefully presenting it later on in the year. But one thing that really struck me already about this process was I imagined it being a lot more of an individual kind of pursuit, as it was a solo. I was choreographing for myself. But I wasn't expecting the people that I was interviewing to become so involved in the project, and hearing their perspectives in their own interviews, but also their reflections after hearing other members and participants sort of talk, and how that gave them a different perspective on the restoration site in general was really interesting, and kind of gave me some ideas of how future collaboration can work in projects like this. All right, I'm going to get into a little bit about how undergraduates can get involved in things like this, just to wrap things up. So as I had mentioned earlier, I am working on a thesis. You can see me in the picture on the right, doing some collection for that thesis out in the field. A lot of programs, and undergraduate programs specifically, have the ability for students to become involved with theses and research. I think it can be a really great way to get more in depth in your education, as well as learn how to manage your own project. And another way that students can get involved with research that maybe isn't necessarily as intense or requires you to have this project kind of on your own is working in a research lab. I'm currently working in the Hallett Lab in the Department of Biology on our University of Oregon main campus in Eugene. And a lot of times, I think it can feel difficult for undergraduates to feel like they can get involved in research because there aren't always postings and listings about when spaces are available. But there are often a lot of labs that will take undergraduates, even just to help out on other projects. And it takes a lot of just cold emailing people, sort of reaching out, seeing if they have anything. And if anyone is an undergraduate looking to get involved in research, I highly encourage doing that. Um, it can be tough not hearing back, but oftentimes, most of the time, it is not personal and labs are just really busy. But if you keep pushing, eventually you'll find something that will work out. Another sort of plug are internships. I did my Oregon Sea Grant Summer Scholars Program over the summer that really got me more involved in science communication and the Marine Reserves Program. I highly encourage people to look into that. The National Science Foundation also offers a research experience for undergraduates program over the summer at various different universities in a lot of different topics. And I particularly am a science communication minor through the University of Oregon. A lot of programs may not have this, but I think in almost any program, there will be people that are looking for ways to connect with other programs. So look for interdisciplinary opportunities and find ways to bridge your interests, even if that's just reaching out to a professor you had for a class and seeing if they might be interested in developing some sort of project or program with you. So a couple thank yous. The Center for Science Communication Research at UO is a huge one. That is really how I got involved with science communication and the science communication minor. Specifically, two of my professors, Alex Sager-Cohen and Torsten Kjellstrand, have been really influential in this process. I'd also like to thank the Redfish Rocks community team, who hosted my internship over the internship over the summer, specifically my mentor, Tom Calvanese, the Oregon Institute of Marine Biology, where I've gotten a lot of my training and have been working on my thesis, especially my advisor, Richard Emlett, Oregon Sea Grant, who made that internship possible, as well as Humbug Mountain State Park, which was, of course, crucial to allowing me to do that junior ranger program at their campground. Got some of my sources here in case you're interested in learning more. And that's it. Thank you all for listening. Please feel free to let me know if you have any questions.
Thank you so much. So that was really great to hear about all the work that you're doing and the importance and value of science communication and what that means, because science is for everybody, right? So thank you very much. Attendees, folks listening in, if you have any questions, I believe you can use the Q&A function in Zoom here, or if you have access to the chat, you can put it there as well. So that's great to hear about all the work that you've been doing, especially at the intersection of art and science. I think that is just so important to make sure that it's the responsibility of everybody to get the word out about the research and the work and making sure that their science is accessible to folks too. So that's really, really awesome. I'm not seeing anything come in, but thank you very, very much, Soph. We try and have these recordings posted on our YouTube by the end of the week. Oh, I just saw the Q&A pop up. Great. All right, so are there any opportunities only for students who are already enrolled in a science program? Or excuse me, are these opportunities only for students who are already enrolled in a science program?
Yeah, so it definitely depends on which specific opportunity and what students are involved in already. I know the Oregon Sea Grant program is open to a variety of different students and interests because you can be more involved in that science communication and organization side of things where you don't necessarily have to have as much of a science background. Um, Maybe more of the communication background is helpful there. Um, for getting involved in research labs, I think a lot of labs are looking to take science students, but that isn't always the case. There are a lot of labs. I know the Sutherland lab at the University of Oregon often tries to involve science communicators in their work. Um, so it really is on a case by case basis and kind of what the specific program is looking for. But if you see some sort of program or opportunity that you're interested in, even if you feel as though it doesn't specifically match your training, I definitely encourage people to just go for it and apply anyway. You never know what might end up coming out of it.
Absolutely. I can back you up on that too. As somebody who's gone down the science road, it's a lot of just putting it all out there and seeing what bites. But also volunteering is really great too. If, like, for example, out here in Newport, you can volunteer at the Oregon Coast Aquarium or with the community teams like us. And that's also a really great way to just start getting some basic experience and some basic science skills, and maybe testing the waters to see if you do maybe want to become a science student as well.
Absolutely. It's never too late to try something new and change your path a little bit.
Yeah. Or just do science as a hobby too. That's fine too.
Yep.
Yeah. Great, great. Well, thank you so much. I don't think we're getting any other questions coming in here. We just have a thank you from the attendee that answered that question or asked that question. So thank you. It's so good to see you again. And I hope that our paths cross again soon.
Yeah, thank you so much for having me.
And thank you so much for attending, everybody. Have a great evening.